Hi guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of Lead Code. So let's get started with the same. So today's question is trapping rainwater, and it is a very good question in order to practice for the interview. So let's get started with this question. So we are given n non-negative integers representing an elevation map where the width of each bar is 1. So we have to compute how much water it can trap after raining. So basically you are given a set of buildings with some specific height, and width of each building is always equal to 1, and we have to find out how much water can it trap whenever it rains between two buildings. So let's get started with the discussion of this question. So we are given some heights, and we have to figure out how much rainwater can we trap, how much maximum amount of rainwater can we trap. So with height 0, as we can already see that there is no building to the left, so no water can be stored in this block, right? And now moving further to the right portion, that is the second, that is when the height is 1. So we can't really store water over here, because since there is no building at this point, so holding water in this segment is not possible. So we can simply jump to the next part, right? So talking about this segment, so can we store water over here? Because yes, that's true, because there exists a difference of heights amongst these two buildings, that is building number 1 and building number 2. So it's pretty easy to store water in this gap, right? So let's continue further. So talking about building number 3 and building number 4, can we store some water over here? Yes, of course, because there exists a difference of heights between the two, and yeah, we can easily store. But this is quite naive to say, but actually what is happening over here is that we are actually trapping water between building number 2 and building number 5. So we can clog a lot of water between these two buildings, because there exists a good amount of height difference between them, that is 3 and 2. Fair enough. So now let's move further, talking about building number 6 and building number, let's call it as 7 and let's call it as 8. So what we can see is that there exists a good difference between building 5 and building 8, so we can easily hold water in this segment. Or rather than saying about 8, it's naive, we can say that there exists a good difference between building 5 and building 7, and the maximum amount of water it can hold is of 1 unit. Why so? Because the moment I try to store water at this level, at level 2, it will basically spill off. So we can at max store 1 unit of water at this place. Now talking about building number 9, can we store water over here? No, because there exists no building to the right of it. So the max amount of water that we can store over here is 1 and 4 and then 1. It comes out to be 6. So while we are looking at this graph, what we are seeing is that we can store water at those places where exists a difference of height, right? We have, what we can see is that there must exist some difference such that we have the maximum on the left, we have some maximum on the left, and we have some maximum on the right, and we can store the water in that slot where there exists where there is a difference, like we need to calculate the maximum from my whole right, from my left part, and I need to calculate the maximum from my right, and then calculate the difference between these heights, and I will be able to trap the water within that difference. Fair enough. So talking about the complexity of this discussion, so one naive formula that I came across is that we need to find the maximum from both left and right, and then we have to find the minimum amongst both of them, and then subtracting it from the height that we existingly have for the building, we can actually store our water. Fair enough. So the time complexity for this solution turns out to be O of n square, and the space complexity is O of n, because in each iteration, after the discussion, what we are basically doing, we are taking the maximum from the left, we are taking the maximum from the right, and then subtracting the height of the building from both of these by taking minimum from both of these, and then we are able to clog water between two buildings. So finding maximum from left at each and every iteration is a tedious job, and finding maximum from the right is also a tedious job. So whenever we try to calculate maximum from left or right for some specific point that we have, like over here we have 0, so it would become quite tedious. So its time complexity is O of n square, space complexity is O of 1. So this is a brute force solution, and now let's move to a better solution, like brute, better and optimize. So let's move to the better solution. So what I can do is, simply I know that I have to track the maximums from my left, I need to track the maximums from my right. So what I can do for a better solution while you are discussing this question in the interview, so what you can do, since we have to track the maximum at each and every for each and every building, so what we can do something like prefix sum. Like rather than just blindly doing the prefix sum, we can find the prefixes from the left which are maximum in height, and the prefixes from the right which are maximum, right? So what we are basically doing is, we are finding the leftmost tallest building at some given building, and the rightmost tallest building at that point for some given building, and then we are calculating the minimum for it, and then we are calculating our answer, which is minimum of left and right minus height at that point, and we will simply calculate the sum of this answer array. Okay, so talking about the left portion, so we are already given the heights of the array. So what is the maximum height at the left of this building? At the 0th index, it's 0. So let's proceed further. So what is the maximum height of this building of height 1? At its left, it's 1. So moving further, so my left max has got updated to 1. So at this point, at this building, what is the maximum height at my left? It is already 1, so I'll continue. So talking about 2, what is the maximum height of a building to its left? It is 2. So I want to make one thing clear. Whenever I'm trying to say that maximum height at the left, it means I am including the current element as well for the comparison. So that's why my answer came out to be 2. So let's jump further on the array. So what is the maximum to the left of 1? It's 2. Continue further, from maximum to the left 2, maximum to the left 2, and maximum to the left of 3, it's 3, because we have included 3 also in our comparison at that point. And now talking about the maximum left at this point, it turns out to be 3, again 3, again 3, and again 3. So now talking about the maximums to the right. So let's store maximums to the right at this point. So what is happening over here is, what is the maximum right that exists at this point? What is the maximum height of the building that exists to the right of this element? It's only 1. of height 1. Okay, fair enough. And what is the maximum height of the building to its right? It's 2. Again over here it's 2. Again over here it's 2. And what is the maximum building of height to the right of it? It's 3. 2 over here it's 3. Again 3, 3, 3, 3, 3, and then 3. Okay, so let's just jump back to the formula that we have derived using the brute force, which is we have to find the minimum height amongst the left max and the right max. So both of these we can find the minimum is 0. Amongst these, minimum is 1, minimum is 1. I'm sorry, the minimum is 1 over here. Okay, I forgot, I don't know what happened. Okay, so minimum over here is again 2, minimum over here is 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 3, minimum over here is 2, again 2, again 2, and then 1. So now simply subtract the difference of heights from both of these. Like, let's subtract this minimum from my height of I. So it's 0, 0 minus 0, it turns out to be 0. Let me change the color of my ink. 0 minus 0, it turns out to be 0. It's not that bright. 0 minus 0, again 0, 1 minus 1, 0, 0, 1 minus 0, again it turns out to be 1. I guess I have missed some calculation at this point, not a big deal. 2 minus 2, 0, 1 minus 2 minus 1, 1, 2 minus 0, 2, 2 minus 1, it turns out to be 1, 3 minus 3, it's 0, 2 minus 2, it's 0, 2 minus 1, it's 1, and 2 minus 2, 0, 1 minus 1, 0. Okay. Yeah, that's correct. So now let's calculate the sum of this answer, and it turns out to be 1 plus 1, 2, 2 plus 2, 4, and then 2, it turns out to be 6. The final answer turns out to be 6 over here. So in this solution, what we have actually done, we have taken 3 auxiliary spaces, that is the left prefix array and the right max, left array and the right array, which are holding the maximum value at left and right respectively, and then we are simply finding the answer at each and every point, which is basically minimum of, which is basically as quoted, minimum of left comma right and minus of my height, that is minus the height of the building. So storing this whole of this answer in one answer array and then calculating the sum of that answer array, right? So the time space complexity in this case turns out to be 2 of 3n. Space complexity turns out to be 3n because we are using actually 3 arrays at this point, right? And moreover, which is similar to O of n, and the time complexity turns out to be 3n because at every point, first of all, we are finding out all the max, all the left max, and then we are finding out all the right max, and then we are calculating our answer for each and every point, right? So time complexity also turns out to be 3n, which is similar to O of n. So in overall, what we can say for the better solution is that we have a time complexity like O of n and space complexity like O of n. So apart from the brute force, it seems to be a better solution, but it is not better because we are using a lot of auxiliary spaces. and the interviewer will not be happy. So let's just move to the optimal solution of this algorithm. Yeah, right. So let's discuss the optimal version of this of this problem, and let's get started. Discuss the optimal solution for this algorithm. So I will take 4 pointers. Like, first of all, it's left and right, which will be initialized to 0 and -1, because the most optimal solution for this problem exists using the 2-pointer approach. So let's get started, and let's just reduce the work that we have done using the array, that we have taken one left max and a right max and continuously finding. So instead we will find out continuously while we are traversing in our array from left to right. Like, we will basically squeeze it, we have squeezed it up something like in the middle of the problem. So let's discuss the solution for the same. Okay, so let's get started. So while I have left less than equal to right, and I'm checking that whether my 0 is lesser than or equal to 1. Yes, it is. So I will update my, so I'll go in this condition, that is my first if condition, where my left is less than equal to right, and if my left is greater than or equal to my max left, so it is 0, greater than or equal to 0. Yes, it is equal to 0. So I'll simply assign my left max, that is 0 to 1. So I have done some dry run also over here. I've done it using a tabulation. So let's discuss the same. So yeah, so after this I have updated my left to 1. My left max is still 0. My right remains at the last pointer. Right max is still 0, and I have contributed nothing to my answer. Okay, so now let's move to the first index, that is 1 less than or equal to 1? It is equal to 1, so I will be standing over here only. So is my 1 greater than or equal to 0? Yes, it is greater. So I will update my 1, my left max to 1. My right max and answer remains as it is, 0 0. My right pointer also remains intact, and my left pointer gets updated to 2. So now let's move to this index. So what we are having 0. Is 0 lesser than or equal to 1? Yes, it is. So now let's compare 0 with the max left. Is 0 greater than or equal to 1? No. So what I will be doing, I'll be adding my 0 to the answer. So my answer gets updated to 1, and my left max is still 1, and my left reaches 3. So I have come up with this, and my right is over here. So is my left, that is my 2, greater than or equal to 1? Is 2 less than or equal to 1? No. So I will be standing, so left part I will not traverse, I will compare my right. So is my 1 is 1. So let's move to this else. Is my 1 greater than or equal to my max right? Is 0 greater than or equal to 1? Yes, it is. So I'll update my right max to 1. I already have my answer as 1, and I will go one step backwards. I'll be reaching over here. Let's mark it with some another color. I'll be reaching over here. That's it. And now let's compare 2 with 2. Both of them are equal. So intact, I will be in the first if, and is my 2 greater than 1? Yes, it is. So my left max get updated to 2, my 1 remains as it is, and my answer still remains 1, and my left gets updated to 4, 10, right remains as it is. So now let's compare my 2. It is at 4th index, 2, 3, 4. My index is over here. So is my left less than or equal to right? 1 is less than 2. Fair enough. We'll be in this condition again. Is my 1 greater than or equal to 2? No, it is not. So I will add my 1 to the answer. So my answer gets updated to 2. Good. And I'll reach over here. So is 0 greater than or equal to 2? No. 0 less than or equal to 2? Yes, it is. I am comparing both of these. So now let's compare my 0 with the left max. Is 0 greater than or equal to 2? No, it is not. So I will simply add my 0 to the answer and my answer turns out to be 4. And I'll shift one step further. I'll come over here. My max still remains 2 and I have reached index number 6. Fine. And I'm still at 10 from the right and I only have 1 as my right max up till now. So now is 1 less than or equal to 2? Yes, it is. So I'll be in my left. I'll be in this if condition. Is my 1 greater than or equal to 2? No, it is not. So I will simply add my 1 to the answer. And my answer becomes 5. And I shift, my left pointer shifts over here. And my right remains as it is. And my answer is updated to 5. So now let's compare 3 with 2. Is 3 less than or equal to 2? No, it is not. So I will shift to my else part. So I'll be working over here. Is my 2 greater than or equal to 1? 1 is the current right max. Yes, it is. So I'll update my answer to 2. And my right max to 2 and my answer remains as it is. So continue further. So I will reach over here. Now let's talk about this one. So is 1 greater than 1 is less than 3, so we will remain in this else condition. Is my 1 greater than or equal to 2? No, it is not. So I will add my 1 to the answer and my answer turns out to be 6. Okay, so and I will reach the final, that is 2. So is 2 less than or equal to 3? Yes, it is. So I will still remain in this else. And is 2 greater than or equal to my max, right? That is 2. Yes, it is equal to my max, right? So my answer still remains 2. So my right max gets updated to 2 and my answer remains 6. And whenever, since my 7 is less than 7 is equal to 7, so I will exit my while loop, and yeah, my solution is done. My algorithm works fine and I've got my answer as 6. So let's discuss the intuition behind it. So all of you might have observed this thing that I am comparing my left with right. Why I am comparing? Because while I am comparing this left with right, because in order to store water we have to have something on the left which is smaller than right. So in order to have that thing, that's why I am making sure in this, by using this condition, I am making sure that there is something smaller to my right. There is something which is smaller on my left and greater at my right, because in this way we will be having some height difference, like we will be having some difference that will exist between two buildings, and in this way we can easily store the water. So that's why this algorithm works fine. But the main check over here is that we need to check that all the buildings to my right, like if my condition that my left height is less than equal to right, if it turns out to be true, it means that there exists some building on my right which are greater in height than the left one, like the existing left is smaller than the ones that are there in the right. It means there are taller buildings in the right. Fair enough. So that's why we can easily assume, we can easily subtract our left max from the given height that we have at that point, because in this way we will automatically store the water. Our water will get stored automatically. That's what the intent behind over here is. And whenever we switch to the else, it works as same, that whenever we try to store the water at the right, it means that we are assuming that we have taller buildings in the left portion. Fair enough. Because if there exist taller buildings on the left side, then only we can store the water. That's what is visible in this image that I have shown so far at the very beginning of this question. Since there exists a taller building at the right, the building of height 3 is taller than the building of height 2 of height 2. That's why only we are able to store the water. And that's why we have put this check of height of left is less than equal to right. And in this way we will approach. And the time complexity for this algorithm is O of n, and the space complexity is O of 1, and this is the most optimal solution that you can discuss with the interviewer. So now it's time to discuss the code for the same, and the code is exactly the same as my algorithm. So I'm checking that both the heights, that there exists a difference of height. If it is less, strictly less, but I've also gone for something like less than or equal to, but yeah, it doesn't make any difference. And I am keeping a track that whether my indices are inbound or not, and I am updating my answer accordingly. So now let's run this solution, and it's working fine. Let's submit it. And the time complexity of this solution turns out to be big O of n, and the space complexity is big O of 1. And this is the most optimal solution for this question, and that's what I can say. So I hope guys, if you have understood this question, please do like my videos. It gives a lot of motivation to me. And if you are new to the channel, please do subscribe. And if you really like a lot, please do share it with your friends as well, because it will actually help me a lot. So that's what on my side as of today. So I will meet you up in the next video. Stay tuned and stay updated with my channel Code with Harsimran. And if you want to connect with me on topics other than the DSA, please do connect with me on platforms that I have mentioned in the description, and I will definitely answer your queries as and when I get my time, and I will try my best to answer all the queries. That's what from my side. Thank you guys. Keep watching my videos. Please do hit the like and subscribe button. That's all I expect from you, and I hope guys that you also accomplish heights in your career. That's what I pray to God for all of you. Thank you everyone, and keep watching my videos.